Limiting reactants. So the concept of limiting reactants is to see which substance we run out first when you combine them, when you make a product. For example, if we have 10 students and 7 desks, okay, and you're asked to pair them, something will run out first. Something will be left over. 10 students, 7 desks. Okay, you're looking at 7 desks is the limiting reactant because the 7 desks will run out first. The question says if you have 30 grams of nitrogen, okay, I'm going to write that down. Nitrogen are mixed with 55 grams of hydrogen. Okay, the product you get is NH3. Unless you have proper specific numbers, something will be left out. Okay, you have 30 grams of N, that's 30 grams, and you have 55 grams of H2. The very first thing we'll do is find the moles of both of them based on the masses given to you. So if I have to look for the moles of the first one, let me go with nitrogen. And also let's balance the equation over here. You have 2 N's and you have a 3 over here. And you have a 2 there. Good, now it's balanced. So let's find the moles of first nitrogen and then hydrogen based on the masses given to you. So you have 30 grams given to you of nitrogen. Cancel that with a mass of N2, which is 28 grams. 28 grams of nitrogen because there's 2 of them. And you go to 1 mole, which is a standard. 1 mole of nitrogen. Okay? So when you multiply 30 times 1 divided by 28, you end up with 1.07. And that'll be moles of nitrogen. Okay, let me go to the side now and go to the moles of hydrogen. 55 grams of H2. Cancel that with 2.02, which is the mass of 2 H's, 2 hydrogens, and you go to the standard 1 mole. 1 mole of H2. When you multiply 55 times 1 divided by 2.02, you end up with 27.2. 27.2, that'll be moles of H2. What these numbers represent is the amount of moles that you have available. That's what you have to work with. Okay, so I like to circle this, and I call this available. I call this. This is what I have to work with. I have 1.07 moles of one, and I have 27.2 moles of something else. When I mix them, something will run out first. It doesn't have to be the smallest one. It doesn't have to be the biggest one. It could be any one will run out first. Okay, to give you the product. Okay, moving on. Now, what I do now, I take one, either the N2 or the H2, and I find the mole ratio of them. I go from whatever I got, 1.07 or 27.2, and I go to the mole ratio. Let's pick 1.07. So I pick 1.07 moles of N2 that I got from my answer, and I go now to the mole ratio. The mole ratio is the amount of moles based on the balance equation. So moles of N2 over here, and I will go to the moles of H2. Moles of H2. And this is based on the balance equation. If I go to the balance equation, okay, and I will bring down, will drag down the N2 and the H2. So from the balance equation, I could see that there's a 1 over here, and I put that 1 right there. 1. I could see that I have a 3 over here, and I put that 3 right there. Okay, so I get 1.07 times 3 divided by 1, I end up with 3.21, and that is moles of H2. So what I have now on that 3.21 is what I need. I need 3.21 moles of H2. Now let's compare. Let's go with H2 and H2 because those are the two ones that I have available here to work with. If I need 3.21 moles of H2, but I have an amount of 27, what I have is an excess of H2 because I only need 3.21, but I have available 27. I have much more than what I need. So since I have much more than what I need, the H2 is in excess. Assuming that one will run out, the other one will continue reacting. Okay. If H2 is in excess, then my N2 is my limiting. Because if one is in excess, assuming that something will run out, if one has too much, then I have too little of the other one. Okay. So I take that limiting number, 1.07, like when I had the students and the desk. The one that determines the pairing is the one that is going to run out. And in this case, the 1.07 is going to run out. So I'm going to use that one to find the mass of NH3. And I go 1.07 moles of N2, which is my limiting. That's going to run out. I go to my standard. I go to the mole ratio now. Mole ratio from the balance equation, I got 1 mole of N2, and I get 2 moles of NH3. This here is from my balance equation, mole ratio from the balance equation. Okay, if I go to the equation, I could see that I have 2 next to NH3 and I have 1 next to N2. So I use those numbers on the mole ratio. Now that I have the mole ratio, I will cancel the NH3 moles with my standard 1 mole. 1 mole cancels to the N2, but the NH3, sorry. Now I go to the mass of NH3. The mass of 1N and 3 H's is 17.03. 17.03 grams of NH3. When I multiply 1.07 times 2 times 17.03 divided by 1 times 1, which makes no difference, I end up with 36.4 grams of NH3. Therefore, going back to the question originally, when I mix 30 grams of nitrogen and 55 grams of hydrogen to form NH3, the amount of NH3 that I get is 36.4.